Okay, so this is the first problem of Div 2 Codechef today's contest. And in this problem, we are given that there are n friends numbered 1 to n seated in a straight line where the ith seat is taken by a friend numbered ai. Now, this Christmas, the friends have decided to distribute candies amongst each other. For each I from 1 to n, the friend at the ith seat will gift one candy to the friend at the jth seat if j is more than I and ej is less than ai. We have to find the number of people who will receive at least one candy. So this is a very simple problem. What we can do, see. So we are given that there are n friends sitting in some order and ai, let's say these are values at I and j. So I will give candy to jth person if I is less than j and ai is more than aj, right? This was the So what we can do in this, instead of looking at it like this, that how many persons will receive candy from ith person, what we can do, we can look at whether this person, jth person, will receive candy or not. So if there is at least one value which is less than, which is more than aj, then aj will, this jth person will get a candy. And how to do it? We don't need any value but the maximum value in this region. So what we can do, we can iterate from left while maintaining the maximum element that we have in the prefix. And if that maximum element is more than aj, then this jth person will get a candy. So we can increment our answer by 1. Otherwise, we don't increment our answer by 1 and we further take maximum as maximum of this. Let's say this underscore maximum. So underscore maximum, comma, aj. So after each iteration, we'll do the same thing because we have to update the maximum element. We have to compute the maximum of prefix. So this is one way to do this. Other way is just maintain a set. And each time when you're iterating over elements, since all the elements are unique, what we can do, we can first insert the element in a set, and then at each element I is between 1 and n, we can check what is the maximum element in the set. If that turns out to be more than aj, simply increment your answer by 1. Both the approaches share the same idea. That is, what is the maximum in the prefix. Is that clear? So let me show you the implementation. So this is the implementation. In this, I have first taken n as input, then I have taken array a as input. In this, I'm using set. So this is it. And initially the answer is 0. So for I'm iterating over each element, I first insert and set. Then I increase my answer by 1 if the maximum element in the set is more than current e. This is the jth aj. Finally, I can print my answer. Is this clear? Okay, so let's go to the next problem. So going to the next problem, we have Chef and Shafina are playing a famous game called Rock, Paper, Scissors. And the game consists of n rounds. In each round, both players choose one of the three moves, either rock, paper, or scissors, denoted by R, P, and S respectively. So if both the players play the same move, the current round ends in a draw. Neither of them wins. Otherwise, rock beats scissor, scissor beats paper, and paper beats rock. So we are given a string A of length n, denoting the moves made by Shafina in n rounds. To win the game, Chef needs to score at least n by 2 points. So we have to find the lexicographically smallest sequence of moves that wins the game for Chef. So first of all, what is the lexicographical smallest? It's nothing but if you arrange the words according to the order they appear in dictionary, then that order is called lexicographical order. And lexicographically smallest is nothing but if let's say this is the order in which these strings appear, then this first string is lexicographically smaller than this third string. So this is a very simple problem, because in this problem again you have to just make sure that you're getting at least n by 2 plus 1 wins, right? So this is what you want. You want n by 2. When I write n by 2, by default it is floor only, plus 1 moves. And if I'm, let's say these are the n rounds. So at the start, how many rounds are left? There are n rounds left. So this is remaining rounds. This is how many rounds you want to win. So if, let's say for the first place, your remaining is more than or equals to what you want. For this remaining, first I'll decrease my remaining by 1. Remaining is n minus 1. I will decrease my remaining by 1. For the first, when I am at the first round, remaining minus equals to 1. So it is n minus 1. So this will give me the number of rounds which are left. Basically these rounds. And if remaining is more than equals to 1, I can have any character here. So out of P, R, and S, what character should I choose for the first? If remaining characters or remaining rounds are more than the rounds that I want to win, I'll choose P. Why P? Because P is the smallest character out of P, R, and S. Basically, P appears first. If you write all the characters, P will occur before R and S. So basically, strings starting with P will occur before strings starting with R and S in dictionary. So I'll write this as P. Now there is a case possible when I will win this round or chef will win this round. When like chef has decided to choose paper as this rounds option. So if Shafina had stone, that is S, then this want will also decrease by 1. So I'll keep doing this. If after some iterations I find that okay, now remaining is equals to want, then I don't have any options. I cannot put blindly P here. I have to win this round. Like chef has to win this round. So in that case, just follow that thing. And if Shafina has paper, chef should have scissor. If Shafina has rock, chef should have paper. And if Shafina has stone, then chef should have paper. If it's rock, then it should be what? If it is paper, chef should have scissor. If Shafina has rock, then chef should have paper. And if it's scissor, then chef should have rock. So this is the thing that you'll follow if remaining number of characters is equals to the number of rounds that you want to win. Is it clear? Yes, no. Is there any doubt? Okay, so let me show you the implementation. So this is the implementation. First, I'm taking n as input, then I'm taking string s as input. This is my answer string that I have to build. This is the number of rounds that I want to win. This is the number of rounds left. So I'm iterating over my string. After this, these rounds are left. If the remaining number of rounds left are more than the rounds that chef has to win, simply push P. But in case the character was R, that meant in current round, Shafina had chosen rock, then by default you are winning or chef is winning this round. So decrease the number of rounds that are needed to be winned from this point. Otherwise, if remaining is equals to want, this is that case only. Remaining can never be less than want. So for that case, just follow these three cases and decrease your want by 1. Finally, we can print our answer string. Is that clear? Okay, so let's go to the next problem. So the next problem is game on array. In this problem, we're given that Elise and Bob play a game with n piles of stones, where the ith pile has ai stones initially. They take alternate turns, starting with Elise. On Elise's turn, she will choose indices I and j. I, j are between 1 and n, where I and j have the same parity. Remove one stone from pile I and j, and now these piles I and j can be same, and both the like if they are different, they should have at least one stone. Like if a pile has 0 stones, it cannot be the pile that is chosen by Elise for removing stone. So on Bob's turn, he will choose indices I and j, where I and j have different parity, and move one stone from pile I to pile j. Now, if a stone is being moved from pile I to pile j, then there must be at least one stone in pile I. So the first player who is unable to make a move loses, and we have to determine the winner of the game if both players play optimally. So, see, we are given some stones in piles. Let's suppose these are the piles. And in Elise's turn, she'll first select two I and J's. The parity of I and J should be same. The position, like. So if I and J, the parity of these should be like if this is I, J can be this thing, or this thing. If this is I, this can be J, J, like these positions can be J, right? Now, in Lice's move, she can first choose I and J, and if I is this, J can be this thing also. Because in that case, also the parity of the position selected is same, right? So, what happens now? After choosing this, Elias will remove one stone from ith pile and one stone from jth pile. And in case I and j are same, then Elias will remove two stones from this pile. So in Bob's turn, I modulo 2 should not be equals to j modulo 2. Like the parity of the indices selected by Bob shouldn't be same. So now in Bob's move, once the two piles have been selected, now Bob will move one stone from pile I to pile j. One stone from pile I to pile j, and pile I shouldn't have 0 stones. In this, pile I and pile j both shouldn't have 0 stones. Or if I was equals to j, then that pile should have more than one stone. But in this case, pile I shouldn't just have one, like should not have 0 stones. So now both of these are playing optimally. Who will be the first person who is unable to make a move and thus lose this game? So if we look closely, see there, let's write some cases. What happens if the total number of stones? See, basically, is Bob removing any stone? In the complete game, will Bob remove any stone? No, right? So if Bob is not removing any stone, the only stones removed are by Elise. And Elise is going to remove stones in every time she's going to remove two stones. So she'll always remove even number of stones. So if the total number of stones is odd, then is there any case in which Bob can win, or in which Alice can win? If total number of stones are itself odd, is it ever possible that Bob will win? There is just one case in which Bob will win, in which Alice will win. If total number of stones are odd, total number of stones are odd, Alice can always remove two stones at once. So there will be at least, after some moves, there will be at least one stone left, and Alice can't remove it. But Bob can like just choose this as I and shift it to another position J. So in that case, Bob will always win. But there is just one case in which Alice will win, and that case is if pile is of there is just one pile, and that pile is having more than one stone. Stones in this pile is more than one. Why? Because see, if there are at least three or two, let's say even two or three, any number of stones, first of all, if it's two, Alice can just remove this, and then there are zero stones left. If there are three stones, like we are considering the case in which there are odd number of stones, if there are three stones, Alice can remove these two stones, and then since there is just one pile, Bob won't be able to make a move. Like Bob cannot choose two I and J such that the parity is different. Right? So in that case, in only that case, Alice will win if the number of stones is odd. Alice will if n is equals to 1 and a of 1 is more than 1, or let's say if a of 1 is more than or equals to 2, Alice will win. Alice wins. Otherwise, always Bob will win. Is anyone having any doubt up till now? Is there any doubt up till now? Is anyone having any doubt in this part? If the number of stones were odd, how I have derived these two cases? Yes, no. Yes, if n is 1, Bob can't make a move, but Alice also won't be able to make a move if AI was 1. If AI was 1, you just had one stone. Bob also, like Alice will also not be able to make a move. Both of them won't be able to make a move, but since we are starting from Alice, so the game will end then and there. But if AI is more than equals to 2, Alice will be able to make at least one move, and after that, Bob won't be able to make a move. So that's why in that case, Bob will win. Otherwise, like in that case, only Alice will win. Otherwise, if number of stones are odd, Bob will always win. Now coming to other cases. So let's look at, let's say these are the stones. So Bob, Alice is able to choose either of these INJs or these, right? Like the parity should be same. And in case of Bob, Bob is able to choose like different parities. So what do we get from him? Let's say number of stones which are at even places, the total number of stones at these are E. Total number of stones in even places, and these are total number of stones in these places are odd. So tell me one thing, after Elise's move, will the parity of O or E change? That like O is total number of stones, total number of stones at odd indices, odd positions, and this is total number of stones at even position. Now tell me, after Elice's move, can parity of O or E change? Why? Why no? Because Elice will remove two stones from odd or even indices, not from one from odd and one from even. It's not possible because the parity of INJ has to be same. Now, if this is fixed, that means before the last move of Elice, this should be true. If this is not true, if the parity of, like, first of all, what should be the parity of these? The parity of these should be how many moves. Now, can someone tell me how many moves are actually Elice going to take? Like how many moves there will be in this game? Hmm? There will be exactly total number of stones divided by two moves of Elice. Why? Because in each move she's removing two stones. So these are the total number of stones. Yes, no. Is anyone having any doubt in this? Like how I came up with this total number of moves by Elice. You cannot have more than these moves. You cannot have less than these moves. If Elice is winning, these are the total number of moves of Elice. And Elice can only win by removing the last two stones, right? Because otherwise, Bob can always, like, Bob moves is very simple. Bob will choose any stone and just move it to some other pile. If Eliza is to win, then it should be that she is the one who is removing the last two stones. Now, how to ensure, like, how to check whether she will always be able to remove the last two stones such that this thing is applicable, that the number of stones, last two stones, are either at both at odd indices or both at even indices. How to check this? Anyone? Like, it's also very simple. How do we check this? See, after Li's move, the parity of these cannot change. What happens after Bob's move? After Bob's move, these will always get changed by one. Always. Because the parity have to be different. So if there are total S by 2 moves and E are the, what is it, even number of Bob moves? See, after Elias's move, the parity of O and E cannot change. After Bob's move, it will always change by one. And there are total number of these number of moves. So can I not find after these number of moves, will I get, like, last two stones before the last move, the last two stones will be at both at odd or one at odd and one at even. Can I not find this? This is the this is the solution to the problem. If it is like this, then Bob wins. Otherwise, if it is like this, that one is at odd, another one is at odd, or both are at even, then LIC wins. Like, actually, the parity, see, you have to do exactly total by two moves, right? If you have to do these many moves, so what we are actually doing after LI's moves, parity of O and E don't change. After Bob moves, parity of O and E both change. So just find how many, if Elice is having these many moves and the last move is in which what Elice wins, so you know how many moves Bob will get. So you will get this thing, and you just have to find after those many moves, like, the stone should either be at odd or at even, not at both odd and even. Is it clear? So if we have total and Elice makes S by 2 moves, So whether this number of stones at even and odd will be like after sth move is determined just by the parity of this total. How many moves there will be, right? Yes, no. Like it only depends on how many moves we are doing. If we are doing like odd number of moves or even number of moves. Only this thing depends, right? Total number of how many total number of moves there will there be. So we just have to check what this is the total number of moves. Let's call this as moves. So if this moves parity is equals to, we can pick any of these. Let's pick even. So if this is equals to the number of stones which were at even indices, if this is true, then what will happen? What will happen? Can anyone tell me? If the total number of moves parity is equal to the number of stones that were at even places. So yes, it is even number of bob moves. So see, I think there is still some confusion. See, this is the total number of moves. Elias, after Elias's move, the parity won't change. After Bob's move, the parity will change. What I want finally, Elias has to remove the two stones, final two stones. If Elias has to remove the final two stones, then those two stones should be at either at even indices or at odd indices. Is this part clear? Okay. So initially, you know how many stones are at odd indices and you know how many stones are at even indices, right? Right? Okay, you know this thing. Now, you know total number of moves is this much. Okay, so you know how many moves Bob will do. If you know how many Bobs will Bob do, so you know how many times these parity will change, right? So if this turns out to be, if even was odd at starting and you did odd number of moves, then what will happen? Who is winning this game? Bob will win this. Otherwise, yes, Bob will win. Otherwise, if this turns out to be that these two are not equal, then Elias will win. Simple as that. So this is what we have to do. So let me just summarize this. First of all, find the total number of stones. If the total number of stones at odd indices, if the first of all find the total number of stones. If the total number of stones is odd, then there is no way Elias will win. There is just one case in which Elias will win, in which the number of piles is one and that pile is having more than two stones. Why? Because if there is just one pile and that pile is having more than two stones, then Elias can make at least one move, and after that, Bob won't be able to make a move. Okay. Okay, there is also one more doubt. What happens if number of moves of Elias is equals to number of moves of Bob? See, Elias is starting first, and we are assuming that last two stones will be removed by Elias. So in that case, Bob will always do one move less than Elias. Why? Because after last move of Elias, there will be no stones left for Bob. Bob won't do any move. Did you get my point? So after this thing, after you have checked this thing, so it means that the total number of stones are divisible by 2 and n is not equals to 1. So in that case, what you can do, you can find how many total moves are will actually be there by Li's, and you can find the number of stones, total number of stones as odd at even indices. Why you have to find this? Because after Li's move, this doesn't change, and after Bob moves, this always changes the parity. So After these many moves, you can find what will be the parity of those. If the parity, like the stones are at even indices, both stones are at even indices, or the both stones are at odd indices, Alice will win, otherwise Bob will win. So the implementation is like this. This is the implementation. In this, I have first taken A as input. This is the total. Now, if n is equals to 1 and the first, like there is only one pile and that pile is having more than two stones, Alice wins. Otherwise, if total number of stones is 2, like total number of stones is divisible, not divisible by 2, that means it is odd, then Bob will always win. So after this case, if there are total number of stones are odd, Bob will always win. Otherwise, just find the number of stones at odd indices, and then like at even indices. If I'm starting with 0, this is even indices. And if this is not same as the total number of moves parity, Alice will win, otherwise Bob will win. If this was same, Bob will win. Any doubt?
No, sir.
Okay. So going to the next problem, we have yet another matrix problem. So in this, we are given an integer n denoting the size matrix A of size n cross n such that Aij is distinct. Aij belongs to 1 and n square. The boundary sum of all square submatrices starting from A11 is odd. For example, this thing, like I'll explain this. If no such matrix exists, we have to print -1. Otherwise, if there are multiple such matrices, we need to print any. So first of all, let's see for odd. Okay. Let's say we have a 5 cross 5 matrix. Like this is a complete construction problem. So like in like any way that you're able to generate the answer is correct. There is no logic behind it. Like how, like there is no data structure involved. There is no kind nothing like algorithm involved in this. It's just plain constructive problem. So the approach that I'm going to discuss is one of the ways to do this. We just need to ensure that we always end up having the correct matrix, like one of the correct matrices. So let's say, first of all, let's write it like this. Okay. Now, what are all these subsquares whose boundary should have odd? So let me draw it. The first one is this. The second one is this. The third one is this. The fourth one is this. And the fifth one is this. So looking at the first one, this is okay. This is correct. The second one is incorrect. Why? Because of like let's remove this is common in everyone. This is one, right? This is common in every boundary. So for all the other boundaries should have even number of odd numbers. Even number of odd numbers. Why? Because this one will always come in all the boundaries. It itself is odd. Or forget about one also. Whatever number you write here will be odd, always odd. Why? Because this is one subsquare, and its sum should also be odd, and it is only having one number. So this thing should be odd. Now, for all the other subsquare, remove this thing, and everything like the number of times the odd number should appear should be odd, not odd, even. Why? So that if you add this odd number to the sum, everything will become odd. So, but if you look at this square, 7, this is occurring. This is occurring like in that. Let me write this. This was 6. So Just give me a second. So let's mark all the odd numbers. 3, 5, 9, 11, 21, 17, 19, 23, and 25. So if you look at every currently each boundary of square in like which has this thing has even number of even number of odd numbers except the square. Every square will have even number. So if every square is having even number, this was 6. If every square is having even number after this thing, then by default I'm getting for every other square other than this, I'm getting a even number. So what I can simply do, I just want for this thing, this thing, this thing, and this thing, I want all of these to have even odd numbers. In these blue paths, I want even odd numbers so that after involving the this one odd, this is also odd, right? If I complete this thing, I will get this path. I'm talking about this path, okay? Like, let me. So when I'm saying that, when I'm saying this path, I meant like if you look at this thing complete, like just don't take this thing and take this thing. How many odd numbers are you getting in this thing? It will always be even, and you have to make it odd. If you make it odd, if you complete this square, you'll get, instead of getting even odd numbers, you'll get odd numbers. So if you're getting odd numbers, the sum will always be odd. But now how to do this? If you look at every square right now, every boundary box, like look at this also. Just don't take the first this element. You will be getting even number of odds. So for everything, and it's true for not just this, true for everything. Like for this also. So you will be getting right now you would be getting odd number of odd numbers in this part. Like if you count it 1, 2, 3, 4, 5. So you have to make them even. If you make them even, eventually this thing will become from even to odd if you take the complete boundary box, right? So one way to do this is just swap these two, swap these two. And if there are further boundaries, swap them also. Like if there are further elements, if they are like the grid is big, just swap them also. Or if you are not like doing it for this second row, you can do it for any other row. Like just swap, like don't take this, but you can swap these two, and like this. And this will ensure that every row or every square grid is having odd number of odd elements, odd number of odd numbers in its boundary. So the sum will be odd. Is it clear? Like this is one way to do this, but this is just for odd. Now, how to do this for even when the grid is of size even? Because if I add one more row here, the issue that we will run into is that there will be nothing to swap this element with, right? So now in the outmost boundary in this thing, the elements will all like if like let's say I have filled like this only up till 5 and I have filled the remaining. Let me, this is 6, no, not, this is 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So this is now extra. But if you look at the last, it now also has how many odd elements? 1, 2, 3, 4, 5, 6, 7, and 8. 8 odd elements. So the sum of the outmost square boundary will be even. Now, how to change this? What I can do, see, always this is true, that this element can be swapped with this in case of even. What will happen? Like this boundary, like where was this element included? In this boundary, and then second in this boundary. So this won't have any effect. Why? Because it was earlier getting involved here, now it is here. So it is still contributing to that boundary, but it won't contribute to this boundary, this outward boundary. So the sum for that will be now odd, and it will be odd for each and every boundary. Is it clear? Is it clear? Yes, no?
Yes, sir.
But this is not applicable in one case. Can someone tell me which case? Like I won't be able to choose the second last row.
When n is equal to 2.
Yes, when n is equals to 2, what will happen? If you choose this element, this will be odd, but you cannot swap it with this. Why? Because our primary target is that this element should still be contributing to its n minus 1th square boundary, but not to the nth square boundary. But if I do this, this will stop contributing to nth square boundary, and now it will start, like it will be still contributing to nth square boundary and not contribute to n minus 1th square boundary. So let me show you the implementation.
Sir, can you solve this problem for n is equal to 4? Like
Yes, yes,
I'm
yes, sure.
I implemented this problem for when n is odd, but in the case of when n is even, I found that the
So
number of
first,
odd numbers should be. Sorry, sir.
yes, 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 I'm doing it. So see, first we'll solve it for n minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, like I said, we'll just swap these two. So 1, 2, 3, 4, 6, 5, 7, 8, 9. So right now for 3, is it correct? 3. It's correct, right? The sum of boundaries is like the sum of this is odd. The sum of this is also odd, right? Yes, no? Then I add 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now the sum of outmost boundary is not odd, so I'll swap these two. So this will become 8, this will become 7. Now everything is correct. Try finding sum for each and every boundary. You'll find, see, sum of this is 1, sum of this is also odd. Okay, now sum of this is again odd. Why? Because this is odd, this is odd, this is odd, this is odd, and this is odd. So 5 are odd. Then sum of outmost boundary. So sum of outmost boundary, this is odd, this is odd, and this is odd, this is odd, this is odd. So only these are odd, right? So again, odd elements are odd number of elements are odd. So again, sum of outmost boundary is also odd. Is it clear? Like first I
Yes.
did this part for n minus 1. I made sure if I like if n was 3, how would I have solved it? Then I added this extra part, and then after adding this part, I know that the answer for the outmost boundary is not correct, so I swapped these two. Is it okay?
Yes,
Yes,
sir.
sir.
Okay, so let me show you the implementation. So in this case, first take n as input. If n is 2, answer doesn't exist. Otherwise, this is your answer grid. If n is odd, simply just fill everything from 1 to like in column row wise order from 1 to n square. Then, like I said, just swap these two. Like in this, I have swapped these two, right? Initially, these two. If there is something here, if let's say the grid size was 5, then you would have swapped first these two, then these two. If there is furthermore, swap these two. So in first row, if the rows are starting from zero index, or in from second row, just swap these two consecutive, like two consecutive elements from second column. So that is what I have done here. So in every column starting from 1, if columns are starting from 0, just swap these two. Otherwise, if n is not odd, n is even, do the same thing. Like I have done the same thing, but for n minus 1. Then I have added extra elements in last column first and then in last row. Like the thing that I've done here. First, I built this part and then I added this 10, 11, 12. Instead of doing it like this 10, 11, 12, 13, 14, 15, 16, I can do it like this also. This is what I've done in code. You can write 13, 14 like this also, it won't matter. Like the sum of outermost square will be even only 13, 14, 15, 16, like this also. If you do, it will be even only. You'll have to swap these two. So after filling the last column and last row, just swap second last row, first element and second element. Finally, we can print our answer grid. Is it clear? So this is just one of the ways to solve this.
Sir, I have not solved the question by using the swap function. I have means I have turned all the diagonal elements into even and their adjacent elements into even, odd, then even, odd, then even, odd. But I'm
Okay,
not able to. But I'm not able to solve this by for n is when n is even.
okay. For n equals zero, that's why n is like for n equals to even, again, like if you're not able to solve it like that, either like you'll have to think in some other direction, because this is a constructive problem. You'll have to add some casework. Otherwise, like you'll have to see whether your logic is like following your logic, whether you're able to find answer in for when n is even or not. Otherwise, if your logic is not working completely, like using this logic, we are easily able to get. If I follow this thing for n equals to odd, like I think for your case also, the same thing will work. For if you're able to find answer for n equals to when n is odd, then what you can do, first find the answer for n minus 1, then fill the last row and column, and then just try to find for each of these, like in for any of these, if one element is, let's say, for any of these, like this element, if this element turns out to be odd, just swap it with its element which is at right side. It is more than enough to make sure that your last boundary also becomes odd, like the sum of it becomes odd. Is it clear?
Yes, sir.
So let's go to the next problem. So in the last problem, we are given that there is a tree with n nodes and k leaf nodes rooted at node 1, and k friends are stationed at node 1, each aspiring to reach distinct leaf nodes. Meanwhile, chef can choose any node, any one of the leaf nodes, and start from that. Now, every second, firstly, each friend will move to one of the children and their current node from their like children of their current node in order to reach the distinct leaf node. Once the friends have moved, chef can move to an adjacent node or choose to remain stationary. When chef and other group of friends occupy the same node, those friends are considered tagged by chef. If multiple friends are present at the same node as chef simultaneously, all of them are considered tagged. Chef cannot tag the same person twice. Additionally, once a friend is tagged, once a friend reaches leaf node, they cannot be tagged. So you have to find the maximum number of friends chef can tag if he moves optimally. So in this problem, see, there is a tree. How many leaf nodes are there in this tree? How many leaf nodes are there in this tree?
Six.
Yes, there are 6. These are those nodes. So initially what will happen, there are 6 friends at this node. After each, let's say after each unit of time, see there's 3 friends will move here, 3 friends will move here, 1 friend will move here. This friend has reached the leaf node. 2 friends will move here. 1 friend will move here, 1 friend will move here. This is happening after each unit of time, right? The friends are moving down. After that, 1 friend will move here. Once friends reach their leaf node, they cannot be tagged. From this, 3 friends will move down. 1 friend will reach here, 1 friend will reach here, 1 friend will reach here. So now what we have to do, given this kind of tree, we have to find chef can start from any leaf node. Like chef can start from here also. In one move, 3 friends will reach here. In one move, chef will reach here. Then chef can stay here. After some time, 3 friends will come here and chef can tag all 3 of them. Or chef can start from here. In one move, chef will reach here. In one move, 3 friends will reach here. In 2 moves, chef will reach here. In 2 moves, 2 friends will reach here. So this way, chef will be able to tag 2 friends. So this way, we have to find what is the maximum number of friends chef can tag, right? So what we can do, see, we just have to find for each node what is the, for each node find what is the distance of closest leaf node. Closest leaf node. If this distance of closest leaf node, if this distance turns out to be less than height of the node or distance from root node, what does this mean? This simply means that chef will be able to reach here before all the friends that will pass from here will reach it, like before at that time. So all the friends that will pass from this node will be tagged by chef, right?
सर एक बार वापस बताना, ये चीज सर समझ नहीं है थोड़ा.
Okay, like for each node, what is the distance of the closest leaf node will give you the earliest time when chef can reach that, right? That node. Yes, no?
Yes sir.
And the distance from leaf node will give you the time taken by friends to reach that node, right?
Yes sir.
So if this distance from root node is more than the distance from the closest leaf node, then this simply means that chef can reach that particular node. See this. So what is the earliest that you can reach this node? You can reach this node from any leaf node after 1 unit of time. Also, friends can like from distance, the distance is 1 only. So basically after 1 node, chef can be here and the friends will also be here. So chef can tag all the friends that will pass from this node. Right now we don't know how many friends will pass, but let's say all the friends that will pass from this node can be tagged, right?
Yes sir.
And now how to get all the friends who will pass from this node? It's nothing but the number of leaf nodes in the subtree of this node. So we have to do 2 things. First is find the distance from root node. That can be done from simple DFS or BFS. The second thing is distance from closest leaf node. So that can also be done using DFS. How? Find for each node, just find, like for leaf nodes, it will be 0. And for any other node, it will be, if it is not a leaf node, it will be, let's say, distance of u is nothing but u, if u is parent of v, is nothing but minimum of distance of u or distance of v plus 1 if u is parent of v. While doing DFS or BFS, if we do something like this where distance is minimum distance to leaf node, then we will be able to get for each node what is the distance, minimum distance to leaf node. And if this distance turns out to be less than height of this node. By height, I simply mean the distance from root node. Like instead of height, I should have said depth, but anyway. So if this is less than, if this distance from root node is more than the distance is more than or equals to the distance from closest leaf node, then every friend passing from this node can be tagged. So for each node for which this thing is true, that leaf node, like uh, the closest leaf node distance is less than or equals to distance from root node, what we can do, answer is nothing but maximum of answer, or the number of friends or number of leaf nodes in the subtree, leaf nodes in subtree of this node. Is it clear?
Yes, sir.
Okay, so let me show you the implementation. So first I'm taking the tree as input, then this count as the number of nodes, number of leaf nodes in the subtree of node I. This is the closest leaf node to node I. Distance I will give me that, and height I will give me the distance of root node, like a distance of ith node from root node. This is my DFS function. If f is 1, it simply means that the ith node or the uth node is leaf node. So I'm making count as 1 and I'm making distance as 0. Otherwise, if v is not equals to p, it simply means that v is not equals to parent of u. Then I'm making f as 0, means this node is not a leaf node. I'm updating the height. I'm calling the DFS function and I'm doing these two things. This is like I'm updating the closest leaf node distance for u, and I'm updating the number of leaf nodes in the subtree of u. Finally, once this DFS function gets terminated, or I return from this DFS function, what I can do, for every node for which it is like the node is not a leaf node, because I cannot tag friends on leaf node. Chef cannot tag friends on leaf node that have reached leaf node. If distance I, that is the closest leaf node distance, is less than the distance from root node, so Chef will be able to reach these nodes first. That is before his friends. So he will be able to tag all those friends. So for this, what I can do, I can just take the maximum of answer and the number of nodes that are leaf nodes in the subtree of node I. Finally, I can print the answer. Is that clear?
Yes, sir.
Okay. So that's it. And thanks for joining.